Hi, I'm David, your developer on duty. Let's have a look at the programming language Zig and get our first impressions. So let's get started. To install Zig, you have to just follow the installation instructions. Here I'm on Mac OS, so I can just run brew install Zig. Now I've already done that, so I don't have to run it again. So now I want to install the Zig language server in NeoVim, so let's do that. I open Mason and go to LSP, and you can see here is CLS, which stands for Zig. I can also search for Zig because there's this keyboard here. Now I can press I to install it, and now I just have to wait. And it's installed. So let's get back to the website. I can now run a Hello World program. I create a directory Hello World, cd into it, and run zig init exe. So let's try it out. Hello World, cd hello world, and now zig init exe. Alright, and now I can run it. Zig build run. It's compiling. And now it prints all your code base are belong to us, which is, I think, an internet meme based on some video game which was poorly translated. So it's nice that Zig has some kind of humor. You notice that the compilation speed is quite slow. This is because Zig uses LLVM as a backend, and I think roughly 90% of the time is spent in LLVM. As far as I know, they're working on another compiler backend which would speed up the compilation process, enabling faster development builds. LLVM is great for the resulting binary, but it's too slow for a quick feedback loop. So there's a lot of going on in this file. First, we use the standard debug print statement, where we say all your something belong to us, and this something will be replaced by code base, and according to the comment it prints to standard error. So personally I prefer this style where you can plug the variables inside the search string, for example here, because that's more readable. Otherwise you always have to look left and right, and that's not so nice. I'm not sure if that's possible in Zig. So here we are logging something to standard out, and it's quite a lot of code. And what's interesting is that this can actually fail, right? So that's why we write here try. That basically means that if this returns an error, this whole function main will just return that error. It's just a shortcut, similar to how Rust does it with this question mark operator. There's even a blog post why there's no print in Zig. So the reason is that printing can actually fail, and you might want to react on that, for example, returning a certain status code. Or you want to create a buffer first and then flush it, like we saw in our Hello World example. So actually this also can be written a bit simpler. Standard out file, print, and then we don't need the flush. So that should also work, and you can see it works. I think I would have preferred this variant in a Hello World application because it's just less intimidating to new users. So here we have also built-in testing like in Rust. This is great, and in my opinion every programming language needs a standardized built-in testing framework. So this is awesome. So here we are creating an array list of i32s, which is similar to Rust's vec. And in the init function, we provide an allocator. And this is a common pattern in Zig. Allocations are not hidden, and allocators must be explicitly provided. And here we're using the standard testing allocator, which only works in tests and can detect memory leaks. And the comment below also tells us that once we comment out this line, the memory leak is detected. So let's first run the test without modifications. So we run zig build test. All tests passed. Now we comment out this line and run it again. Zig build test. And now the memory leak is actually detected. So what actually is defer? Well, it just means that it's executed at the end of the scope. So you could have also written it like that. So without defer at the end of the scope, list the init. If I run it again, it still works. So the good thing about defer is that now it's visually combined, so you can write the init right after you called init, and it's close together and enhances readability. Zig also comes with a default formatter, which is opinionated and doesn't allow you to change things, which is great because then we have a consistent style across all code bases, and I do think all programming languages should have that. So if I write something, list append 42 with a lot of spaces and I write my file, then it's automatically formatted, which is great. Of course, the zig comes with various data types, for example, structs. So let's define one. Const, let's say vec2 equals to struct. And here we have the property x, f32, and y, f32. And zig allows you to have trailing commas, which is nice. And the formatter also takes that into account. So once you remove this trailing comma and you format it, then you can see it gets inlined, which is kind of neat. So let's keep it at several lines and create one. Const my vec equals to vec2 dot x equals to, let's say, 12 dot y equals to 13. And you can see that unused local constants are declared as an error. So let's just print it. Standard debug print. Now I have to provide here any, and here I give my vec, and let's run it. Sig run source main. And you can see my vector is correctly printed. It's also possible to define methods on structs. So for example, here I can say function dot, it takes self, which is my vec2, and another one, which is also a vec2, and it returns an f32. And here I just say return self.x plus other.x plus self.y plus other.y. So let's call it. I define another vector with, let's say, 22 and 23. And now I want to log my vec dot other vec. Let's see if that works. Yes, it works. There's also a different way how to call it. You can also write vec2 dot dot and now provide those two vectors as the arguments. And also here it works. Zig doesn't have generics like in Rust, but there's a feature called comp time, which lets you evaluate functions during the compilation time. That's a neat mechanism which lets you, for example, abstract over types. Let's try it out. So instead of having a vec2 for f32 as a fixed type, let's just create a function which takes a type and returns a struct using that type. So we create a function anyVec, which takes a comp time parameter, which we call t of type, and it returns a type. So here we can return a struct, and we can just paste the content as before. But now we have to be a bit careful because now our types are actually t's, which we get from outside. And here we can also refer to this by writing const self equals to add this, and then we just replace them. So let's get rid of our old vector and use it in our new code. So we can say const vec2 equals to any vec2 of f32, and here we use the other notation again. And let's see if that works. Yes, it works. We can also define functions which take a comp time parameter and return something else than a type. So let's say we have this function .it, which takes a comp time parameter called t of type. We get a v1 of type t and a v2 of type t, and we return an f32. And here we return v1 dot v2. Now let's call it here. So we write .it with our vec2, my vec, and other vec. So let's see if that works. And we get the right result. So what happens if this method is not available on this type? So let's call it .t for now, which is not defined in vec2. Let's see what happens. It fails, and it fails during build time, which is great. That means Zig doesn't need a complicated trait system to define the allowed properties. It just checks the property access during build time. And the error messages are great. Error, no field or member function named .y in main anyvec f32. So let's fix our error. And now it runs again. Zig also has support for enums, so let's create one. Const result equals to enum, and here we can say it is either okay or not okay. So let's construct one. We can say const is okay equals to result okay. And one nice feature is called switch, which is similar to Rust's match. So we can say const my string equals to switch is okay. Now if it's okay, then we can say alright. And if it's not okay, we can say oops. And of course we have to use this dot notation here. And now we can print it, standard debug print. We print it as a string. And here we provide my string. So let's see if that works. Yes, and it prints all right. Let's look at the error messages if we misspell something. And you can see we get a nice error message, no field named OK in enum main result. That is perfect. And the other thing which is a common mistake is to forget one of those variants. So let's remove this not okay one. Let's run it again. And also here, switch must handle all possibilities. Unhandled enumeration value, not okay. Also perfect. And if we want to handle other values, we just write else, oops, which is similar to the underscore in Rust. So let's try it again. It still works. Unlike in Rust, we cannot just attach some payloads like i32 and f32 here. So this is not allowed. This gives an error. But we can create unions. For example, const result union equals to union. And here we can say OK is of type i32 and not OK is of type f32. So let's construct it. We can say const is OK2 equals to result union. And here we can say OK is equal to 12. And then we write standard debug print. Let's say any, we don't care. And here we can say is OK2 dot OK. So let's see if that works. Yes, 12 is printed. So let's try to use it in a switch statement. Const my string 2 equals to switch of is OK2. And if it's okay, we say hello. And if it's not okay, we say oh. Now let's print it. My string 2, and you will see that this leads to an error because it says switch on union with no attached enum. So in order to fix this, we attach an enum to our union, and we already have such an enum. It's our result enum from before. So if I do that, then it works and we print hello. All in all, I find Zig to be very interesting. I like that it comes with a built-in test framework and formatter. Having errors as values is great, and the try syntax is comfortable to use. Comp time is such an awesome mechanism and really easy to grasp, so no more complicated traits like in Rust. And proper data types like enums, unions, tagged unions, and so on allow for good data modeling. And there are also a lot of other great features which I haven't talked about, like async programming without the blue-green function problem, compile time reflection using type info, cross-compilation, optional types instead of null pointers, seamless integration with C, and the performance is awesome. There are also some things I have to get used to, for example manual allocations and deinitializations. I understand the reasoning, it makes sense, but it's a bit cumbersome to do. I'm looking forward for Zig to develop its package manager and to introduce another compiler backend for faster compilation and hot code reloading. I'm excited about the future of Zig and will definitely keep an eye on it. It's really a breath of fresh air for systems programming. What's your take on Zig? Please post it in the comments. Thanks for watching and stay tuned.